If you don't understand HVAC fans, you don't understand airflow. And airflow is the foundation of every HVAC system, whether it's a rooftop unit, a data center, or a massive warehouse. But here's the problem. Most people only recognize fans by what they look like, not how they perform. And that's exactly why systems get designed wrong, installed wrong, and even estimated wrong. In this video, we're breaking down the most important HVAC fan types, what they actually do, where they're used, and how to identify them instantly in the field or on plans. This is video 1 in our HVAC fans series, where we break down the real-world components you'll see across commercial and industrial systems. Whether you're an estimator, project manager, designer, or new to the industry, this video will give you a clear understanding of how fans actually move air and why different types exist. Because not all fans are created equal, and choosing the wrong one can completely change system performance. Let's start with the most recognizable type, axial fans. Axial fans move air in a straight line, parallel to the shaft. Think of a propeller, pulling or pushing air directly through the fan. But not all axial fans perform the same. There are 3 main types. Axial fans equal straight-through airflow, but performance depends on the design. Propeller fans, used in very low-pressure applications like wall exhaust or warehouse ventilation. Tube axial fans, designed for slightly higher pressures, often installed in duct systems. And vane axial fans, which include guide vanes that straighten the airflow and allow the fan to handle much higher static pressures. These are used in more demanding applications like tunnel ventilation, industrial systems, large-scale exhaust, and in older built-up HVAC systems where they are being replaced with plenum fans. So, while axial fans are known for moving large volumes of air, some types, especially vane axial fans, can also handle moderate to high pressure. The key takeaway is this. Axial fans equal straight-through airflow, but performance depends on the design. Centrifugal fans. Centrifugal fans work differently than axial fans. Instead of moving air straight through, they pull air into the center and discharge it at a 90-degree angle. This allows them to generate higher static pressure, making them ideal for ducted systems. You'll find centrifugal fans in air handling units, VAV systems, ducted exhaust systems, most commercial HVAC applications. But not all centrifugal fans perform the same. There are 3 main types you'll see. Forward curved fans. These use many small blades and are designed for high airflow at lower pressures. They're commonly found in smaller air handlers and older HVAC systems. Backward inclined fans. These use fewer, larger blades and are more efficient. They handle higher pressures and are common in modern commercial systems. Airfoil fans, a type of backward-inclined fan with a more aerodynamic blade shape. These are the most efficient and are typically used in higher performance applications like large air handlers and data centers. So while all centrifugal fans are built for pressure, their efficiency and performance depend on the blade design. Plenum fans. Plenum fans are a type of centrifugal fan, but with a key difference. They don't use a traditional housing or scroll. Instead, they discharge air directly into a plenum space. This design eliminates the need for duct transitions and allows for more flexible layouts. You'll commonly see plenum fans in large air handling units, built-up AHUs, data centers, high-performance commercial systems. They're also often arranged in fan arrays, sometimes called fan walls. This improves redundancy and allows systems to continue operating even if one fan fails. Fan walls, fan arrays. Fan walls are exactly what they sound like, a wall of multiple smaller fans working together. Instead of one large fan, you might have 6, 8, or even 12 smaller plenum fans. Why? Redundancy. If one fails, the system keeps running. Efficiency. Fans can ramp up and down based on demand. Maintenance. Smaller fans are easier to replace. These are becoming extremely common in data centers and mission-critical facilities, especially where uptime is everything. Propeller fans. Propeller fans are a basic form of axial fan, typically without a housing. They're simple, cost-effective, and used in wall exhaust fans, warehouse ventilation, agricultural buildings. But they're limited to very low-pressure applications. Once you introduce ductwork or resistance, their performance drops quickly. How to identify fan types? Here's a quick way to identify fan types in the field or on plans. If air moves straight through, axial. If air turns 90 degrees, centrifugal. If there's no housing and it discharges into open space, plenum. If there are multiple small fans in a grid, fan wall. Understanding this alone will immediately improve how you read plans and visualize systems. Why fan selection matters. Choosing the wrong fan isn't just a design issue. It affects everything. Airflow delivery, energy efficiency, noise levels, system reliability. For estimators, this impacts cost. For project managers, this impacts performance. And for field teams, this impacts installation and troubleshooting. Now that you've seen the different types of HVAC fans, the next step is understanding how each one actually performs in the real world. Because not all axial fans are the same, and this is where a lot of people get it wrong. In the next video, we're breaking down axial fans in detail, including propeller fans, tube axial fans, and vane axial fans, and when each one should actually be used. If you want to understand HVAC systems beyond just recognizing equipment and start thinking like an estimator, designer, or project manager, this series will walk you through it step by step. And if you're looking to go even deeper into HVAC systems, estimating, and real-world applications, check out the full courses and resources linked below. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business, and explore our online courses for in-depth training.